Good morning, good afternoon, good evening. Welcome back to Chapter 5. We're going to move on from transport. Now we're going to talk about metabolism. I think I said before that cells are miniature chemical factories. Factories produce goods. Some places break stuff down, and that's what your cells do. They do both. They are producers and decomposers. They break down food molecules to get the energy out of them, and then they use the particles and the energy from those food molecules to build new molecules. Metabolism is some of the reactions that take place inside of a cell, and those reactions are one of two categories. They're either making or breaking. Breaking releases energy. Making consumes energy. Cells are chemical factories. They're conducting thousands of chemical reactions at any given moment, all the time. That's what they do. That's their job. Their job is to make products, break down food for energy and building materials, and use those building materials and energy to make new products that your body needs. They're amazing little things. Energy itself is called the capacity to do work, and let's pause for just a minute and talk about that. The capacity to do work, this is actually work. Work is a definition. Work has a formula in physics, and that is force times distance. You apply a force to an object, and you move it a distance, and that's called work. You need energy to apply that force. Energy is the capacity to do work. And cells require constant and abundant supplies of energy so they can do their work, so they can build the molecules you need to stay alive, so they can break down the food molecules that you take in to power your body so you can stay alive. Energy, it all boils down to energy. There are a variety of different types of energy. Thermal energy is heat. IR stands for infrared. You know, an IR camera looks at heat. Infrared is heat. Thermal energy. Heat is the lowest form of energy. The lowest form of energy in the universe. It has the least amount of energy in it. And to be fair, is not really that useful as far as powering things. Heat isn't really that useful in powering things, at least not in your body anyway. It's useful to make things happen faster, but it's not that useful for powering reactions. Radiant energy is light. Your phone is showing light to you. Your laptop is displaying light to you. In this video, your desktop is broadcasting light at you. That is radiant energy. The sun puts out radiant energy. The light bulbs in your house put out radiant energy. If you spend a lot of time in the sun, what happens? You get darker. That's because of UV. UV stands for ultraviolet. It's the specific wavelength. It's the series of wavelengths that cause your skin to get darker. Chemical energy is predominantly what your body runs off of. Your body, you take in chemical energy in the form of the food that we eat. Your body then takes the chemical energy from the food and converts it into chemical energy that your body can use to power those reactions it needs to take place, to power the chemical reactions it takes to stay alive. Chemical energy. Some, actually a lot, most of that chemical energy that we take in as food, we actually lose as heat. Remember, heat, lowest form of energy. Anytime you convert anything from one form to another, in this case we're talking about energy, anytime you convert energy from one form to another, you're always going to have waste. And in this case, that waste is heat. We actually use that waste to stay alive. We like to be warm. We like to be a certain temperature. And not all organisms do. Not all organisms keep a constant body temperature. Humans, we do. So that heat that is wasted in these chemical reactions that we do isn't truly wasted in us, but as far as the universe is concerned, heat is a waste product. If we're going to talk about energy, we need to talk about thermodynamics. Thermodynamics means the movement of heat, the movement of energy. The first law of thermodynamics is the amount of energy in the universe is constant. That means there is a certain amount of energy in the universe, and that's it. There's only so much. You can't create it. You can't create energy. You can't destroy energy. All you can do is change its form. If you stop eating, you are not going to be creating any energy. You're not taking in any energy. You will eventually die from lack of energy. It's going to take a few weeks, depending on how much energy you have stored, but you're going to die. You can't make it. The way you get energy to power your body is by eating food that was made ultimately from the sun. The radiant energy from the sun is taken in by plants. Plants use that energy to take carbon dioxide and water and to make sugar out of it. And so if we eat a vegetable, that's where that energy came from. If we eat a hamburger, the cow, where did it get its energy from? How did it build its body? It got it by eating grass. And the grass got the energy from the sun. The ultimate energy source for all living things on the planet is sun. It's always the sun. Energy and therefore matter can neither be created nor destroyed. You can only change its form. What happens when you change forms of energy? What always happens is you always lose. You always have a net loss of energy. Some of the energy is always lost and wasted as heat. The second law is my favorite law. The second law is entropy is increasing. Now the question is, what's entropy? Entropy is disorder. Disorder is increasing. Disorder is more stable than order. Let's do a thought experiment. I want you to imagine what would happen if you didn't clean anything in your apartment for a week. When you finished a cup and you put it down, that's where it stayed. When you finished a plate and you put it down, that's where it stayed. When you took your clothes off to get in the shower and they fell on the floor, that's where they stayed. You didn't put a single piece of trash in the trash can. You didn't wash a dish. You didn't wash a stitch of clothes. You didn't put anything away. You didn't do anything. What would your apartment look like after a week of not cleaning, not putting anything away? It would probably look like this or worse. This is entropy. This is disorder. Then your mom calls and says she's coming over on Sunday. If your place looks like this on Friday when your mother calls, what are you going to have to do all day Saturday? You're going to have to spend the whole day washing all those dishes, the whole day washing all those clothes, vacuuming, picking up, taking out the trash, and at the end of Saturday, after you worked all day to clean your apartment, are you going to be tired? Are you going to be exhausted? Did you have to spend energy to fight entropy? Disorder is easy. Disorder is actually more stable than order. It's really easy for your apartment to turn into a pigsty, isn't it? It costs energy to fight disorder and to put things the way they're supposed to go. Life fights entropy.